Welcome back. Today we're going to look at adding and subtracting rational expressions again. This is section 8.5, but our focus today will be on these complex fractions. So a complex fraction is just a rational expression that has a fraction as its numerator, denominator, or both. So it's fractions within fractions. It can be simplified by the following process. There's actually a couple different methods for simplifying. The process that we're going to use is to create a single fraction in the numerator, create a single fraction in the denominator, and then we can multiply by the reciprocal. So I want you to extend this middle fraction bar. All right, so you can see that we have some mini fractions in the top and we have a fraction and a constant in the bottom. We need to create a single fraction on top. That means we have to get a common denominator for this top part. So the 1 over x, 1 divided by x, plus x divided by y, we have to convert that into a single fraction. The LCD for this top part would need to have an x and a y. So my first fraction here, this 1 over x, is missing the y. If I need to multiply a y in there, I have to multiply 1 on top. And the second fraction has the y, but it's missing the x. So I'd have to multiply top and bottom by an x. Now, that top half is a 1y plus an x times x, or x squared, all divided by an xy. We have a common denominator now, so we can add those numerators. Now we're going to do the same thing on the bottom half. All right, looking at our fraction. Let's put a 1 under this just so we can see the little mini denominators. Our LCD on the bottom, we have a y and a 1, so our LCD would just be y. So the first fraction is fine. 1 divided by y is fine. The second fraction, or the second piece of this, is just a 1. We need to have a y in the denominator, which means we have to multiply the numerator by y. So my denominator is going to have a y in it. My numerator is now going to have 1 plus 1 times y, or 1 plus a y. Okay? So we've done the first two steps here. We've converted the top into a single fraction. We've converted the bottom half into a single fraction. Now this line says we are dividing these two fractions. So we are going to actually multiply by the reciprocal. So we're going to have y plus x squared divided by xy. And we're going to multiply by the reciprocal of the blue part. So we get y over 1 plus y. All right, then we look for anything that we can reduce out. In this case, we could reduce out this y, 1 there with 1 there. And what we have left then is a y plus x squared on top and an x times a 1 plus y on the bottom. And we could distribute that x out, y plus x squared divided by x plus xy. Okay, I'm fine with you leaving it in this form as well. All right, let's try another one. Again, find that middle fraction bar that's the real division sign for this problem, okay, and extend it so we can really see the two halves here. Now the top is just a single x, so we're going to just leave that. I am going to put a 1 under it so we can see that as a fraction, but it's really just a plain x. The bottom fraction, we have 1 over x plus 1 over y. Our LCD down here would need an x and a y. So the first fraction is missing the y, and the second fraction is missing the x. Okay, we now have a common denominator of x times y. That means we can go ahead and combine all of this top stuff into a single quantity here. There we go. So we have 1y plus 1x, or x plus y. You can write it as y plus x plus y, it doesn't matter. Okay, now we can multiply by the reciprocal. So we're going to have x divided by 1, and we're going to multiply by the reciprocal of this purple part. So the xy moves to the top, and the x plus y moves to the bottom. Now we don't have any common factors here. Remember, we cannot reduce this x with this one, because this is not really an x, it's a whole x plus y group. Okay, so all we can do is simplify. We have an x to the first, another x to the first, that gets me x squared. and a y on top. On the bottom, we simply have an x plus y. All right, let's try one more of these. A little more complicated looking here. Again, that's my split. For these whole numbers, like the 4 here, I'm going to put a 1 under it. The 2, I'm going to put a 1 under it, just so we can see it as a fraction. And the LCD for the top and the bottom, actually, our LCD is going to need to be an x plus 3. So we need to get all of those little mini denominators to be x plus 3. So on the top half of this, the first fraction is fine. We have an x plus 3 in the denominator. We can keep that. The second fraction is going to need an x plus 3 multiplied both to the numerator and denominator of it. So the top half of this, we're going to have 2 over x plus 3 plus, and if we distribute that 4, we're going to have a 4x plus 12 over an x plus 3. So we have that common denominator now of x plus 3, and the numerator, when I combine these terms, we end up with 4x plus 14. Okay? We're going to do the same thing now on the bottom half. So my first fraction is fine. I have a 5 over x plus 3. My second fraction, though, I need to multiply by an x plus 3 to both the numerator and denominator. Be careful here. Notice this is a minus 2, so we're going to go ahead and distribute that negative 2. Negative 2 times x would be negative 2x. Negative 2 times the 3 would be negative 6. And again, we have a common denominator of x plus 3. Combining all of our top pieces, we get negative 2x minus 1. All right, so we have a fraction, a single fraction divided by a single fraction. We're going to flip and multiply. So we have 4x plus 14 divided by x plus 3. We're then going to multiply by the reciprocal of this. So we're going to flip this over and have x plus 3 divided by negative 2x minus 1. Okay? Before we do any kind of reducing, let's think of this in factored form. We could factor a 2 out of this 4x plus 14. It would leave me 2x plus 7. So I'm going to think of it in that terms, just so I can look for common factors I can reduce out. In this case, it doesn't help me a whole lot because I don't have any factors that match either the 2 or the 2x plus 7. But I do have an x plus 3 here that I could reduce out. So my final answer is 2 times 2x plus 7, all divided by a negative 2x minus 1. Okay, let's look at one more example here. This one is talking about fuel economy. It says a woman drives an SUV that gets 10 miles per gallon. Our abbreviation for that is going to be MPG. Her husband drives a hybrid that gets 60 miles per gallon. Every week they travel the same number of miles. And that's kind of key here to what we're going to be doing, so I'm going to underline that. They want to improve their combined miles per gallon. They have 2 options on how they can improve it. Option 1, they can tune up the SUV so it increases its mileage by 1 mile per gallon. So it was 10 miles per gallon. This would make it 11 miles per gallon. And then they would keep the hybrid as it was. Okay, so it would still be 60 miles per gallon. Option 2, they can buy a new hybrid that gets 80 miles per gallon, and they can keep the SUV the way it was, and the SUV was 10 miles per gallon. Which option will give them a better combined miles per gallon? Okay, so when we look at combining it, our combined gas mileage is the total miles divided by the total gallons. So we're going to take the SUV miles and the hybrid miles and add them together. We're going to take the SUV gallons and the hybrid gallons and add those together. So total miles divided by total gallons. We're going to let X stand for the number of miles that each drives in a week. And it says they both drive the same amount. So the man and the woman are both going to be driving X miles each week. All right, let's look at option 1. It says we're going to tune the SUV so it gets 11 miles per gallon, and we're going to keep the hybrid at 60 miles per gallon. We're going to define each variable and then describe our options that way. Okay, now to figure out the number of gallons that are used, we are going to take the miles and divide by the miles per gallon. Okay, and I want you to think about that for a minute. If we take miles and divide by miles per gallon, that's the same as saying miles times the reciprocal, gallons per mile. And so you can see that the miles will drop out and we will be left with just gallons. So that's how we're going to figure out how many gallons the SUV and the hybrid are using. All right, so option 1. We need SUV miles plus hybrid miles. Our SUV miles and our hybrid miles, we were told that they both drive the same amount. So that's just going to be X plus X. The SUV gallons is going to be found using this conversion here. Okay, so we have SUV gets 11 miles per gallon, and so we're taking X miles, I'll put it over here, X miles, we're going to divide by 11 miles per gallon, which means we're really taking X miles times 1 gallon for every 11 miles. Our miles will drop out and we get X divided by 11. So our total SUV gallons is going to be X divided by 11. Okay, using that same thing for the hybrid. The hybrid gets 60 miles per gallon. So again, if we take X and divide it by 60, we're going to get the total gallons used for the hybrid. All right, to simplify this, we need to get a common denominator in the bottom half of this. The numerator is fine. X plus X is just 2X. Denominator, though, we need to get a common denominator. So for this bottom part, we have an 11 and we have a 60. Our LCD is going to be 11 times 60, or 660. So we want a total denominator here of 660. The first fraction has the 11, it's missing the 60, so we're going to multiply by 60. The second fraction has the 60, it's missing the 11. Okay? So we end up with 60x plus 11x all over 660. All right, so we have 2x. We're dividing by 60 plus 11 would be 71x over 660. So we're going to multiply by the reciprocal. So 2x, again, I'm going to think of it as 2x over 1. Think of it as a fraction. My reciprocal of the green part here would be 660 divided by 71x. And the only thing I can reduce out of that would be the x's. So I'm going to have 2 times 660, which is 1320, divided by 1 times 71, which is 71. And we end up with a combined miles per gallon of 18.59. Okay, that's option 1. All right, we're going to do the same kind of thing for option 2. This time with option 2, the SUV gets 10 miles per gallon and the hybrid gets 80. So total gallons for the SUV is going to be X divided by 10. Total gallons for the hybrid is going to be X divided by 80. All right, so let's set it up. Option 2, combined miles per gallon. So total miles was X for the SUV and for the hybrid. The total gallons for the SUV was X divided by 10, and the total gallons for the hybrid was X divided by 80. Okay, so again, simplifying. The top just gets us a 2x again. The bottom half of this now, we need a common denominator. We have a 10 and an 80, so our LCD here would just be 80, which means the second fraction's fine. The first fraction would need to be multiplied by an 8. So we end up with 8x plus another x would be 9x. And then again, we're going to multiply by the reciprocal. So we're going to have 2x divided by 1 multiplied by the reciprocal of the green part. So 80 over 9x. And again, the x's would drop out. We end up with 160 divided by 9. And that comes out to be 17.78. So our better combined miles per gallon. Option 1, we had 18.6 roughly. Option 2, we have about 17.8. Option 1 is going to give us a better combined miles per gallon. All right, let's look at a couple more. I take that back. That is the same thing we just did. All right, then I think we are finished. Let me know if you have any questions.